Welcome to WWDC. My name is Eric. I'm an engineer from the Maps team. Today, I'm joined by my colleague Yingshu, and together we're going to explore what's new in MapKit. It's been 3 years since Apple Maps introduced its all-new map and its immersive look-around experience. Originally launched with US support, the all-new map and look-around coverage has been expanding since and now includes Canada, many European countries, Japan, and more. Last year, Apple Maps took things to the next level by introducing 3D city experiences, featuring turn lanes, crosswalks, bike lanes, and beautifully handcrafted 3D landmarks like the ferry building. The additional detail of the map allows you to provide context and precision that was never before possible. And the addition of 3D terrain elevation provides a level of realism like no other map. This year, MapKit brings the latest innovations from Apple Maps to your apps, letting your users explore the world in amazing details. In this talk, we'll be covering several new MapKit features. First, we'll talk about adopting the all-new map and fully leveraging it using the Map Configuration API. Next, we'll cover various improvements we made to our overlay APIs to allow for a seamless integration of your content with the map. We'll also discuss our new blend mode support and show how you can make use of it to further enhance the presentation of your map content. Then, we'll cover ways of making your maps more interactive by adopting our brand new Selectable Map Features API. And finally, we'll cover integrating the immersive look-around experience directly into your applications. We've got a lot to cover, so buckle up as we head for our first topic, adopting the all-new map and using the Map Configuration API. Adopting the all-new map in your iOS, macOS, or tvOS application couldn't be easier. Simply recompile your app with the new SDK, and it will be automatically opted in to the all-new Apple Map, including the 3D city experience where available. For many applications, a simple recompile is all that's needed. Of course, there may be situations where you need more control over the presentation of the map. In iOS 15, the way you configure the map is through various properties on MKMapView. In iOS 16, however, we're soft deprecating these properties, and we're introducing our new Map Configuration API as a replacement. MKMap Configuration is the central class of the new Map Configuration API. MKMap Configuration is an abstract base class with 3 concrete subclasses. The imagery map configuration is used to present satellite-style imagery. The hybrid map configuration is used to present imagery-based map with added map features such as road labels and points of interest. The standard map configuration is used to present a fully graphics-based map. These 3 map configurations may sound familiar to you as they are similar to our existing map types. The base map configuration class supports an elevation style property, which can be either flat or realistic. A flat elevation style means that the ground appears flat. Roads, including bridges and overpasses, also appear flat. Flat is the default elevation style. A realistic elevation style means that the ground terrain reproduces the real-world elevation, such as hills and mountains. Roads are depicted with realistic elevation details. Now let's take a closer look at the map configuration subclasses. The imagery map configuration only shows satellite imagery with no additional map features, so it doesn't have any other properties. The hybrid map configuration has additional properties to control filtering of point of interest categories and whether to show traffic or not. The standard map configuration supports an emphasis style property, which can be either default or muted. As the name implies, this is the default emphasis style unless otherwise stated. The muted emphasis style softens the contrasts of the map details, allowing you to bring more attention to additional graphical information you might want to show on top. The standard map configuration also has additional properties to control filtering of point of interest categories and whether to show traffic or not. And that sums up the available map configuration classes and their properties. This new API ensures you can only configure supported combinations of options. It also allows you to change the map configuration atomically. We think this is a great improvement over our existing APIs. To recap what we just discussed, here's a table that shows the correspondence between the new map configuration classes and the MKMap type property. The all-new map with the 3D City experience requires compatible hardware. On iOS, the new map support requires A12-based iPhones and iPads, or later. On macOS, the new map support requires any M1-based computer or later. In areas where the 3D City experience is not available, the map will automatically fall back to present the all-new map with a flat elevation. On all other devices, the all-new map will be presented with a flat elevation. On M1 Max, Xcode allows you to simulate both experiences simply by changing the OS version. We encourage you to try out both to ensure that your app looks great on all devices. The 3D City experience is available in many metropolitan areas around the world. We're continuously adding new cities to this list, so I encourage you to check out the 3D City Experience section on the Feature Availability website linked in the session notes. This concludes our section on adopting the all-new map and using the Map Configuration API. Now, let's dive into overlays. MapKit has supported overlays with several styling options for years. In iOS 16, we are improving our existing APIs to allow your overlays to seamlessly integrate with the map. Let's start with a quick recap of overlay levels. Overlays can be rendered at two different levels, above roads and above labels. You can specify the rendering level at insertion time using one of MapKit's many overlay insertion functions. Above labels renders your overlay above everything, including labels. Since labels provide important context information, we encourage you to only use above labels in those rare cases where you don't want your data to interact with the map at all. If what you're trying to achieve is for your content to stand out against the map, you might want to consider using the muted map emphasis or the blend modes, which we'll talk about later. Above roads means the overlay will be shown on top of the terrain, including roads, land cover, or bodies of water. It will, however, be shown below labels and to some degrees, trees and building. More on that in a second. Above roads will be the new default mode in iOS 16. Next, let's talk about a new feature we're introducing in iOS 16 called transparent buildings. Regardless of whether your overlay level is above roads or above labels, your overlay will always be rendered on top of buildings when viewed top-down with no pitch. However, we've made some improvements to the experience when using above roads in combination with a pitched map. Ground objects, such as trees and buildings, are now automatically rendered with transparency when appearing above overlays, so as not to fully obscure them. The alpha value varies with the map's pitch angle. If we revert to showing the map top-down with the 0-degree pitch angle, colliding ground objects effectively disappear from view, leaving your overlays fully visible. Transparent buildings also work for semi-transparent overlays. The alpha value of the overlay will be added to combine with the alpha value of the transparent buildings. And there's one more change we're making to overlays. When adding an overlay to a map with realistic terrain, MapKit will automatically transition the map to a flat representation. The map will automatically go back to realistic when you remove the last overlay. One notable exception to this rule are overlays sourced through MapKit's Directions API. Those overlays automatically follow the terrain. And with that, I'm going to hand it over to Yingshu.
Thank you, Eric. Hi, I'm Yingxiu. I'm an engineer on the Maps team. I'm going to demonstrate our new MapKit features and show you how easy it is to build beautiful map experience with our updated APIs. I'll be using our sample app, which helps users rent scooters to tour San Francisco. Our app offers a number of features as shown by the rows in this table view. Operating area allows the user to see where they can take our scooters. Ride takes the user on a tour across the Golden Gate Bridge. Explore gives the user an interactive map of downtown San Francisco, which they can use to explore attractions near the waterfront. Highlights offers a closer look at must-see places. We will implement or upgrade these features throughout this session. Let's get started. First, I'm going to use the operating area feature to demonstrate how easy it is to adopt the all-new map. And then I'll show you some of the improvements we have made to overlays. I already have the project opened in Xcode. Let's compile it with iOS 16 SDK and see how it looks. Here we are. We already opt into the all-new map. We get a map view with rich details, including these beautiful lighting and hill shading effects on the terrain. As we zoom in, you will see buildings, trees, and landmarks. Now let's add a polygon overlay to visualize our operating area. Here, I already have the polygon data ready for the operating area. When the view is loaded, we'll first set the region and the camera boundary. Make sure we look at the correct area. Then we simply add the overlay. Let's build it and check it out. The polygon overlay is opaque when viewed straight down. As we zoom in and pitch, buildings begin to show, with the transparency increasing as we pitch further. This effect is only available when using the overlay level above roads. If you want to leverage transparent buildings and trees, make sure you choose the correct overlay level. The overlay looks great, but I like the map to show through even when not touched. Let's go back to the code and make it semi-transparent. Change alpha to 0.8. Now we have a transparent overlay and I can see roads and buildings even when not pitched. If I zoom in and pitch the map, I still get an increase in transparency. This looks great. That's it for polygon overlays. Next, I want to show you how to integrate realistic terrain and show adding an elevated route line. This will complete our ride feature, a tour across Golden Gate Bridge. Let's start by configuring the map view. We can change the elevation style in code, or we can just open the Interface Builder inspector on the right-hand side. Here are the available map view configuration settings. Let's select Elevation Realistic. Next, let's work on the route. For this feature, we want to show a route when the user toggles the Show Route switch. We will also animate the camera to focus on the route. Since we want to show a route across the Golden Gate Bridge, we will use Presidio Park entry as the start point and the Battery Spencer as the endpoint. When the map view is loaded, we will create annotations to mark the start and destination points. Set coordinates and title, appended to the annotation array, then add them to the map view. Now we can focus on the route polyline. While normal overlays will flatten the map, polyline returned by MapKit Direction API will preserve the realistic terrain. In this action function, once the switch is turned on, we will create place marks with the coordinates defined above. Then we create a direction request with source and destination. Finally, we request the direction If the fetch operation succeeds, simply add the route polyline as an overlay. Alright, let's compile it and see how it looks. You notice the annotations are automatically upgraded to the new gradient look. They are also seamlessly displayed at the correct elevation. Once I toggle Show Route, the camera will pitch, then you get a better view of them. As you can see, the route line follows the elevated terrain. This comes in handy when navigating complex intersections. It also follows the road across the bridge. Also, notice how the route subtly shows through the bridge pillars. Finally, when the map is really pitched, you can see the route show through the trees that stand in front of it. Well, looks the route line color is washed out here, where there's no trees. Let's zoom out and check what's happening here. Alright, this part of the route goes through a tunnel, so we get transparency for it. Elevation realistic style and the elevated route line feature are supported on A12-based iOS devices. If I run the same app on an older iOS device, I will automatically get a 2D route on a 2D map. It's that simple to add elevated route line to 3D City Experience map. With that, I hand it back to Eric.
Thanks, Yingshu. That scooter ride across the Golden Gate Bridge looks absolutely stunning. So that's just some of what's new with MapKit overlays. Next up, let's talk about blend modes. This new API gives you more control over the look and feel of your overlays and unlocks a whole range of new creative possibilities. I'm sure many of you are already familiar with blend modes from photo editing apps or Apple's Core Graphics API. During a blend operation, two graphical layers are combined following a set of equations specified by the blend mode. Now, let's look at an example of how we might use blend modes in a MapKit context. In this scenario, I want to highlight the area of the Presidio National Park in San Francisco in the center of this map. First, I'm going to create an overlay covering my entire map area with a cutout in the shape of the Presidio. I'm not using any blend modes yet. This is just a plain overlay in the shape of a big square donut. Next, I assign a hue blend mode to the overlay with a gray fill. This desaturates the map outside of the Presidio. Next, I'm going to duplicate that overlay and assign it a hard light blend mode with a dark gray fill. This has the effect of darkening the area around the Presidio. This already looks nice, but let's add another overlay. This time, we'll add an overlay in the shape of the Presidio and assign a saturation blend mode with a yellow fill. Whoa, that's not exactly the effect I was aiming for here. The colors are way too bright. Let's try something else. We'll apply a color burn blend mode with a gray fill. There, that's a little more subtle. It's perfect. Now let's look at some code. To enable the kind of effects we just saw, we added a property to MK Overlay Renderer called Blend Mode. All you need to do is set the desired Core Graphics blend mode on the Overlay Renderer and you're done. As previously mentioned, blend modes are order dependent. The overlay at the bottom of the stack is blended with the map. The second to last overlay is then blended with the result of the previous blend operation, and so on. In MapKit, the order of overlays is determined at insertion time. You can use either absolute or relative positioning using one of MKMapView's many overlay insertion functions. MapKit supports a wide range of blend modes, and we can't possibly cover all of them today. I encourage you to try them out. And that's it for blend modes. As you've just seen, blend modes are a powerful tool to control the styling of your map. You can use it to highlight geographical areas, de-emphasize the map to make your content stand out, and so much more. Next up, let's talk about selectable map features. This has been a highly requested feature, and I'm really excited to show it to you. If you're using MapKit in your app today, you're likely leveraging annotations to show the location of cities, points of interest, or physical objects. Unless you're using POI filtering, you're placing those annotations on a map which already contains a number of similar annotations provided by Apple. Up until now, your users could only interact with the annotations you provided. In iOS 16, we're going to change that. Using our new Selectable Map Features API, you'll now have the option to let your users select features on the map. Selectable map features include points of interest, such as stores, restaurants, and landmarks, territories, such as cities and states, and physical features, such as mountain ranges and lakes. To adopt selectable map features in your app, all you need to do is go through a few simple steps. First, configure which feature types should be selectable. As we just saw, there are 3 main feature types, and it might not make sense for all of them to be interactive in the context of your app. For points of interest features, you can also use our existing filter API to further restrict which points of interest categories can appear and therefore be selectable. Second, implement the MKMapView delegate callbacks to handle selection events. You are free to handle those events however you choose. You might want to control how selected features appear, or you might want to show some additional UI in response to the selection events. Third, you'll want to request and display additional place information in your application's user interface. The information embedded in the map feature is limited to what you see on screen. To give users more context about the place they selected, you'll need to request additional information. Let me walk you through the new APIs for each of these steps. We'll start with configuring which map features should be selectable, using the new Selectable Map Features property. You can choose any combination of points of interest, territories, and physical features. Once you've configured the selectable map feature and the user taps one of those features, you'll start receiving some new delegate callbacks, allowing you to customize the selection behavior. The first callback you'll get is the new didSelect annotation callback. This callback is a great opportunity for you to request additional data about the map item using the new request API we'll cover in a moment. The second callback you'll get is the existing view for annotation callback. This is where you can customize the view which will be shown for the selected state. While this is existing API, we've added a new type of annotation class called Map Feature Annotation. This class will be passed to view for annotation when the user selects a map feature. Map Feature Annotation has a number of properties. You can inspect the feature type property to determine whether the map feature is a point of interest, a territory, or a physical feature. If the map feature is a point of interest, the point of interest category property will let you know what its category is, and the icon style property will let you obtain additional information about the icon, such as its background color and the icon image itself. Let's look at an example of how to customize your annotation view using the View for Annotation callback. If you want to achieve the same selection style as the Maps app, all you have to do is return nil. If you want to customize the selection style, you can return an annotation view the same way you would for your own annotations. The marker annotation view is a great option. It will give you the same balloon-style shape as the Maps app, a gradient treatment, and it allows you to choose your own color or icon. In my example here, I've chosen to use the same image obtained from the feature's icon style and only change the color to match the application's tint color. If you want to go fully custom, you can provide any annotation view subclass that you create. As you just saw, you can use the feature annotation to retrieve visual information about the selected feature. By passing the feature annotation onto our new MKMap item request API, you can also retrieve a map item for the selected feature. This map item contains additional metadata about the place, such as an address, a name, a phone number, and a URL. The map item also provides a function to punch out to the Maps app if your users want to see additional metadata which isn't available through MapKit. And now, I will again hand it over to Yingxiu.
Thank you, Eric. Eric just walked you through the selectable map features. I'm going to show you how easy it is to leverage that API. For that, we will implement our Explore feature. We want our users to be able to explore some interesting places near the waterfront. If they tap on poise, annotations should show up. We will perform a camera animation to the tap location and show an info card from the bottom. First, let's filter points of interest on the map and remove the categories which are irrelevant to our tour. Aside from applying the filter in code, we can also apply it in the Interface Builder Inspector. Let's select the map view and go to Inspector on the right-hand side. Here, we will do an exclusion filter. I'll select the categories that we don't want. For example, airport, car rental, hospital, and laundry. Now we should only have desired points of interest on the map view. It's very simple to enable selectable map features. All we need to do is to specify an option set of desired selectable features. In the scope of this sample app, we'll just use points of interest. But keep in mind, we also support selectable physical features and territories. We can use the existing delegate method, mapView, view for annotation, to create a view for the feature annotation. Here, we'll just return nil for now. To use the default gradient annotation offered by MapKit. We'll come back to customize it later. If an annotation is on selected state, we will be informed through the new delegate method, mapView did select annotation. Let's use this function to perform a camera animation and zoom in on the selected feature. First, let's cast the annotation to feature annotation. Then create a map item request with it. This is a new API to fetch additional place informations with feature annotations. Let's issue the request. Once the fetch operation succeeds, we will animate to the map item. When the camera animation has completed, we will get details from the feature item and show them on an info card. Compile it and see how it looks. Let's check out some interesting places at the waterfront. The gradient annotations show up, the camera animates to the tap location, then the info card shows up. This is a museum, here is the URL, we can check it out if we're interested, and we get the full address. If it's a landmark, we will get this beautiful iconography. Now let's go back to the code and customize our annotation for the selection state. Instead of nil, let's create a marker annotation view. We'll cast the annotation to feature annotation first, so we can use specific data from it to customize the view. Let's tint the annotation with a purplish color, so that's in line with our corporate identity. We can also customize the annotation glyph. Selected glyph image is for annotations on selected state. Glyph image is smaller. It is the glyph for annotations on unselected state. We recommend assigning them the same glyph for a smooth transition from unselected to selected state. Let's use the icon style image we got from the feature annotation. MK icon style is a new class in iOS 16. It has the iconography and color info of the selected point. Compile and see how it looks in the app. Here you go. Now we have an annotation that matches our corporate colors but still uses Apple iconography. That's how you can enable selectable map features and customize annotations in your own apps. With that, I hand it back to Eric.
Thanks, Yingshu. As you just saw, the Selectable Map Features API enables your users to interact with the map in a whole new way. The Map Feature Annotation class, in combination with the MapViewDelegate callbacks, allow you to customize the selection look and feel, while the Map Item Request allows you to resolve a feature to a map item, giving you access to additional information about the selected map feature. Next, let's talk about Look Around. The Maps app introduced Look Around in iOS 13, and people absolutely love it. You can use Look Around to get a real sense of a place. Look Around imagery offers an incredible level of detail, leveraging 3D models to provide a level of realism like no other map. Look Around is available in many places around the world, including these cities and entire countries. We're continuously adding support for new regions, so I again encourage you to check out the Look Around section on the feature availability website linked in the session notes. With iOS 16, we're bringing Look Around to MapKit, and adopting it only required 3 simple steps. First, you'll need to check whether data is available for the desired location. Even if Look Around is available in your target region, not every location can be seen from a street, and therefore, Look Around imagery might not always be available. Once you've determined whether Look Around data is available, you'll need to pass the data onto either a Look Around view controller or the Look Around snapshotter. And finally, if Look Around data is available, you'll want to update your app UI to show the Look Around preview. Let's take a look at the new APIs you will be using to accomplish those 3 simple tasks. The first step in attempting to show a Look Around preview is to check for data availability. For this, you'll need to create a Look Around scene request, which is a new class we're introducing in iOS 16. You can initialize a new instance with either a coordinate or a map item. Next, you'll want to retrieve its scene property. This is an optional async property. If data is available, you will get back a scene instance. If data is not available, you will get back a nil instead. And if there was a problem with the request, an error will be thrown. The Look Around scene is an opaque object with no properties. It acts as a token that ensures the availability of Look Around imagery for a requested location. To show an interactive preview of the Look Around scene, you simply pass the scene on to a new Look Around view controller instance as an init parameter, or assign it to the read-write scene property of an existing instance. Alternatively, if all you need is a static image, you can also pass the scene on to a new Look Around view snapshotter instance as an init parameter, and subsequently retrieve its snapshot async property. The Look Around view controller is designed to make it as easy as possible to embed a smaller static preview of a Look Around image, which the user can tap on to enter a full-screen Look Around interactive session. And now, we'll hand it over to Yingshu once more so she can show us how easy it really is to put it all together.
Thank you, Eric. Eric just showed us the immersive Look Around experience support coming to MapKit. I'm going to show you how straightforward it is to integrate it in our sample app. For that, we will move on to our last feature, highlights. Users can get a realistic view of must-see places. We already have a couple of San Francisco landmarks name in the segment control bar on top of the screen. When users tap on one of them, we want to perform a camera animation to the tapped location. We also want to show a Look Around preview at the bottom left, which our users can expand to full screen. Let's do it. First, we need to add a container view for our look-around preview. Let's go to the size inspector. Let's give it a position and size. We want to hide this preview at the beginning, so let's open the Attributes Inspector and check Hidden. Next, we need to create a look-around view controller. And embed it to the container view. Same as any other segue, I need to give it an identifier. Let's call it Present Look Around Embedded. And import it to code so we can update its visibility later. Let's name it Preview. Here, we already have a look-around view controller declared. We just need to grab the instance in the prepare function. Make sure the segue identifier is matched. Then, in the segment control function, we'll create a local search with the landmark name. If the request succeeds, we will get a map item, which will be used in the following camera animation and look-around scene retrieval. For camera animation, we first need to create a camera with the new API. Map camera looking at map item. Let's use the map view frame size for the view size and set allow pitch to true. This will give us a pitch view to landmarks and a top-down view to other places. Assign the new camera, that's it. Once the camera animation is completed, we will show its look-around preview. First, we need to determine if the look-around data is available for this map item. To do that, we need to use the new look-around scene request class. Let's create our request and pass in the map item. Then perform the request. If getSceneRequest succeeds, just assign the scene to our look-around view controller. If there is no error, but we get nil for the scene, it means look-around data is not available at the request location. Finally, don't forget to show the preview. Let's see how it looks in the app. Let's try with the ferry building. There you go. The ferry building is a landmark, so we see this fantastic curated camera framing to its hero angle. And the look-around preview shows up. Let's try with another place, Dragon Gate. Dragon Gate is not a landmark, so we get its top-down view. Let's tap on the preview to enter full screen. It's an interactive view, so I can navigate around. I also get these beautiful icons and labels for stores in the look-around full screen view. It's that easy to add an immersive look-around experience in your own app. With that, I hand it back to Eric.
Thank you, Yingshu. The interface builder support for Look Around makes it look so easy. So, we've covered a lot of topics today. From the automatic adoption of the all-new map and the new map configuration API, new behaviors and advances for overlays to all new capabilities like selectable map features and look-around support, we think you'll agree there's a lot here you can use to take the map experience in your app to the next level, and we can't wait to see what you'll accomplish with it. Before I go, there's a few things I'd like to leave you with. As always, your feedback is instrumental in helping us prioritize what we focus on next, so please be sure to use the feedback assistant to send us your bug reports and the features you'd find most helpful for your app. In addition, we've updated many of our existing samples to incorporate what we just discussed. We encourage you to check them out. And finally, we've announced a new set of REST APIs you'll want to take a look at. We think these APIs will be really useful for those of you looking to move common calls for geocoding, ETA determination, and more to your server. For all the details, be sure to check out the session titled Meet Apple Maps Server APIs. On behalf of the Maps team, thanks for watching and have a great WWDC.